Good morning, good afternoon, good evening. Welcome back to Chapter 1. We just got done talking about taxonomy. We just got done talking about how life is classified: domain, kingdom, phylum, class, order, family, genus, species. At the time, I said there are three domains. The three domains are eubacteria, archaea, and eukarya. When I was in college, there were only 5 kingdoms. There were not these things that we call domain. The 5 kingdoms were plants, animals, fungi, these things called protists, which we'll talk about later. And then the last kingdom was something called Kingdom Monera. And Kingdom Monera is where we put bacteria, and these other things called archibacteria. Those things were all prokaryotes. Those things were things without a nucleus. And the people that studied bacteria and archaea said, look, these two groups shouldn't be classified together. The only thing that they have in common is the fact that they don't have a nucleus. After that, they're really nothing alike. If you want to say that the difference between you and a tree is the difference between kingdoms, then these two things are more different than that. So we need something even more different than kingdoms. And so they said, well, okay, so what we'll do, instead of making another kingdom, is we'll make these broader classifications called domains. Within every domain, there are many kingdoms. Kingdom Eubacteria, what does eu mean? We said this before. Eu means true or good. So eubacteria means true bacteria. The reason why we call them true bacteria is because the name for these things called archaea used to be archibacteria. Well, if we have bacteria and archibacteria, and we've come to find out that archibacteria aren't even bacteria, just kind of cut that name off and forget anybody ever knew that word. That's why it's called true bacteria. True bacteria are bacteria. We'll talk about bacteria later on. A staph infection is a bacterial infection. Strep throat is a bacterial infection. Lots of different things. Syphilis is a bacterial infection. Bacteria. They're the most diverse and widespread of the prokaryotes. Remember, before the nucleus. The other group of prokaryotes are archaea. Archibacteria, we'll talk about them much later on. And forgive me, we're not supposed to say archibacteria anymore because then it makes you think they're bacteria when they're not bacteria. Archaea. Archaea are, we call them extremophiles because they're often found in very extreme environments, like saltwater evaporation ponds, like acid pools, like super hot water, like really, really, really dangerous, really, really hazardous ecosystems. And that's why they got the name Archaebacteria, because, well, they're prokaryotes, so therefore they must be bacteria. They're not. What does archae mean? What does an archaeologist study? What does archaic technology mean? That's that skill I was talking about, that skill of trying to figure out what a word means. The way you do it is you look at the word, and then you go through your mental dictionary, and you bring out all of the words that you know that have that root in it, and then you look at what all the meanings are. Well, what does archaic mean? Well, it means like archaic technology, like, really old. What does an archaeologist study? Oh, they study like fossils and things like that, stuff that's like really old. So what does archae mean? Really old? Yeah, actually it means really old. It actually means more than that. It means ancient. So archaea, it means ancient. And so the name Archaebacteria meant ancient bacteria. And it was believed that they were the first bacteria because they were found in these really hazardous environments that we think the early Earth was probably like really dangerous, really hazardous environments. No, they're not the first bacteria. They're actually more related to us than they are to eubacteria. Science learns. Eubacteria, archaea. The last group is eukarya. We talked about eukaryotes, true or good, nucleus. The other 4 kingdoms, remember I said there were 5 kingdoms when I was in college: plants, animals, fungi, protists, and then Monera. Monera got split out into these 2 domains. All those other 4 kingdoms, plants, animals, fungi, and protists, they all got put together in what we call domain eukarya. These things are more similar to each other. You are more like a mushroom. then archaea are like bacteria. Here we see some of these different living things. We see domain Eubacteria, all right, bacteria. Domain archaea, single-celled prokaryotes. Both of these are single-celled prokaryotes. All of the other pictures on here are for domain Eukarya. Plants, animals, fungi, and these things called protists. And again, we'll talk about protists much later on. The simple definition for what is a protist: it's a eukaryote that doesn't fit into these other categories. That's what a protist is. It does have a nucleus, but it's more complicated, or rather, excuse me, it does have a nucleus and is therefore more complicated than these two groups, but it's not complicated enough to be in these other three. How do we go from single-celled prokaryotes to multicellular eukaryotes? Well, you have to give it a really long time, but if you do give it a really long time, what happens is, as organisms live in a particular environment, they will accumulate adaptations that allow them to live better in that environment. Because there are many different environments, that's many different places where organisms can branch out and live. And if we allow those organisms to exist in these varied ecosystems over a very long period of time, they will accumulate so many adaptations that they don't resemble the original organisms that they used to be. And again, we're not talking about an individual. We're talking about a population. We're talking about a population that colonized this area, and then 10,000 years later, or 10 million years later, now there are still organisms in that area, but they look very different than they did 10 million years ago. This process is referred to as evolution. This is a change in gene frequency over time. We've seen evolution happen in so many places. Evolution is not a guess. Evolution is fact. It is an observable fact. When populations are exposed to environmental pressure, meaning, example, if you take antibiotics, that's going to kill off most of the bacteria in your system, the bad antibiotics. If I take a couple doses of antibiotics, it's going to kill off the ones that are weakest to that antibiotic. So it's going to leave behind the ones that are resistant to that antibiotic. They have a gene that allows them to not be weak to the antibiotic. So before you took the medicine, we had a 1% population that had this gene that allowed them to be resistant, and a 99% population that didn't have that gene, right? So 1 versus 99. I take the medicine for a couple of days, and I kill off all of the ones that aren't resistant. So my only population left that reproduces, it keeps reproducing. The only population left is the one that are resistant. So now, what is my resistant percentage? Well, now it's 100% because I killed off the ones that were weak. That is a change in gene frequency over time, and that is evolution. That bacteria have evolved. Are there multiple species of bacteria that are resistant to antibiotics? Yes, there are. How did they get resistant to antibiotics? By being exposed to them a lot. But that's why you shouldn't take antibiotics for just a few days. If you continue to take all of them, what happens is you're basically bombarding the bacteria with the antibiotic to the point to where even though they are resistant to it, that doesn't mean that they're 100% resistant, and you keep hitting them, and eventually will kill all of them and get rid of all of the bacteria that are making you sick. Evolution, change in gene frequency over time.